So I'm going to take a quick little look at finding or factoring and expanding with the difference of squares and its application for quick maths, or quick mental math, that is. But I'm going to back up a little bit. Before we talk about factoring, we're going to talk about expanding. Now, expanding just means multiplying using the distributive property. So right here we have two binomials, bi meaning two, nomial meaning terms. So here's one binomial, and here's our second binomial. And we are multiplying these two binomials together. So what that means is we're multiplying everything in the first binomial to everything in the second. So we're going to have a times a. Well, what is a times a?
A squared.
A squared. By the way, I have a lovely assistant with me helping me out. What is a times negative 15?
Negative 15a.
Negative 15a. So this is nothing totally crazy, and I am using my mouse pad to draw, so please have patience with me. What is 15 times a?
15a.
That's 15a, that's right. And what is 15 times negative 15? Well, that is negative 225.
Don't they just like...
Now, we have to combine the similar terms. We have no other a squareds, so that we have nothing similar to the a squared. So that gets dropped down because a squared plus 1 is a squared. Negative 15a plus 15a is 0. Because if I have 15a's and I take 15a's away, they cancel out. And again, I have no other plain numbers, so there's nothing to combine it with. So I have a squared minus 225. So let's take a closer look at this result. A squared minus 225. Well, a squared is a perfect square because a times a is a squared. 225 is a perfect square because 15 times 15 is 225. So we have two perfect squares, and we are subtracting 225 from a squared. Another word for subtracting is a difference, and that's where a difference of squares gets its name. In its expanded form, you have two perfect squares that are being subtracted from each other. Now, more complicated problems can have more variations, but we're just talking about simple expanding and factoring of a difference of squares. Well, what does that mean? If in the factored form, we have the same terms, only one is adding and one is subtracting. We have a plus 15 and a minus 15. So what that means is, if I look at my second problem, I have k plus 11 times k plus 11. I have the same terms, but I'm adding in one binomial and I'm subtracting in the other. Therefore, we have a difference of squares again.
Well, that means that those ones equal out.
That means, yes, that's exactly right. The middle term, this linear term, will cancel out. So I don't actually have to go through and multiply everything out. I will simply know that I will end up with k squared, because k times k is k squared, minus 11 squared, which is 121. And the 11k and the negative 11k will cancel out. So this is a difference of squares. And that is expanding. Well, we can turn it around the other way. We can turn an expanded form expression into a factored form expression really quickly. So notice how I have two perfect squares right here. I have c squared and 49. C squared is a perfect square because it's c times c, and 49 is a perfect square because it's 7 times 7. And I am subtracting them, therefore I have a difference of two squares, difference of squares. And when we factor a difference of squares, we are going to end up with a pair of binomials. That's two binomials. Remember, binomial means
two terms.
Two terms. All right, so what times what is c squared? Well, that's just c times c. What times what is 49? 7 and 7. And we need it to be a negative 49, so that means I have one positive and one negative.
You should get a touchscreen computer then.
Yeah, I know, if I had a touchscreen computer, it would be so much easier.
I just do it on mine, but
yeah, okay. All right, so I hope you enjoyed your little break. So same idea here. 9d squared is a perfect square because 9 is, I heard you next, we're recording here, so we don't want to have that conversation. So 9d squared is a perfect square because 3 times 3 is 9, d times d is d squared. 144 f squared is also a perfect square because 144 is 12 times 12, so it's a perfect square, and f times f is f squared. And I'm subtracting these two perfect square terms. So that means I have a difference of squares. And to factor a difference of squares, I will again have a pair of binomials. One is going to have a plus symbol, and the other one's going to have a minus symbol. So what's the square root of 9d squared? Well, that's just
3d squared?
3d, because d times d is d squared. So we have 3d and 3d. And what is the square root of 144f squared? Well,
12f.
There you go. And so we factored it pretty easily. Well, how's that work for fast mental math? Well,
Quick maths.
the quick maths. So we have 1015 times 985. I cannot do this problem in my head unless I use the principle of a difference of squares. So I know that another way of writing 1015 is simply 1000. It looks like a kid or kindergarten writing. Plus 15.
Oh, so you do 100 times 9. Oh, that's like what we did in like 3rd grade.
So
4th grade, actually.
well, everything builds on each other. So 985 can be written as 1000 minus 15. Well, 1,000 times 1,000, well, that's just simply, how many zeros is that? That's 6 zeros. 1, 2, 3, 4, 5, 6. 15 times 15, because we know the middle term is going to cancel out, right? I don't have to do 15 times 1,000. Just 15 times 15 is
225.
225, and I just have to subtract them. So we're going to have lots of 9s, right? 9, 9.
Wouldn't it just be like smarter
9.
just like write it down on paper and do
9.
regular long multiplication?
9. Now you could do that, but that would actually take a little bit longer. So 5, 7, 7, and then we have our 9s. 1, 2, 3, and there we go. So that was pretty quick. Another way we can look at this is, let's say we have perfect square numbers. Let's say we have, oh, I don't know, 10 squared minus 3 squared. Now obviously we could do this without using the difference of squares, because 10 times 10 is 100, 3 times 3 is 9, right? And so 100 minus 9 is, you got it,
91.
Right, 91. But we could also look at it like 10 plus 3, because the square root of 10 squared is 10. The square root of 3 squared is 3, times 10 minus 3.
Does this only work if it's subtraction?
Yes, it only works if you have a difference, and that's why it's called the difference of squares. Now, 10 plus 3 is 13. 10 minus 3 is 7.
Wait, what? 10 minus... Oh,
Yeah, 10 minus 3 is 7, believe it or not. And guess what? 13 times 7 is also 91. So we can take this problem and turn it into a difference of squares and get the answer pretty easily. Now, obviously 10 and 3 are pretty small numbers. You don't have to use the difference of squares. But what happens if it's 10,000 squared minus 500 squared? I don't want to square those numbers. So this way, I can turn it into a difference of squares and make it a much easier problem. All right, so that is a quick run through of how to use the difference of squares principles to do some quick mental math, or at least make math a little bit easier when you don't have a calculator.
Well, that help I do. So it's pretty much just